Hello dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. So today I will discuss about the refuse derived fuel, that is RDF. So first of all, this is the functional element of municipal solid waste. So in the municipal solid waste whole system, it will be started from the waste generation to its primary collection, then waste handling and storage. And after this waste handling and storage, secondary collection method will be there. So after the secondary collection methods, it will be passing throughout the different processes. First is the transfer and transport, and after that processing and transformation. So for processing and transformation, what are the methods has been involved, and how to transform the waste into a useful matter, how to find resource from the waste is coming under this category, that is the transformation. So that in this way we are studying about the waste as a fuel. So waste as a fuel, for this RDF will be there. RDF is called as refuse derived fuel. So after this transformation, the waste will be goes for the final disposal practices. This is the functional element of municipal solid waste management. So it will be starts from the waste generation, then after waste handling and storage, primary collection methods, and in the secondary collection methods, two steps are there: transfer and transport. And the secondary collection method will involve processing and transformation. So from processing and transformation, next step will be there, that is called as disposal. After this processing and transformation, the waste will goes for the final disposal. So before that, what are the different techniques to extract energy from the waste, to extract some useful material from the waste? So for this, we are going to study waste as a fuel, and what is this RDF? That is refuse derived fuel. So waste as a fuel, like we'll discuss about the waste to energy plants will be there that are going to burn the municipal solid waste, that is basically called as garbage or trash, to produce steam in a boiler that is used to generate electricity. So in a boiler, this garbage, this trash or this solid waste has been burned out, and by the burning of this trash, this solid waste, heat will be coming out, and this to produce the steam in the boiler, and by this steam we are going to generate the electricity. So what is MSW? Municipal solid waste is a mixture of energy rich materials like paper, plastic, some yard waste and products that are made up of from wood, and this waste to energy plant reduces 2000 pounds of garbage to ash weighing about 300 pounds to 600 pounds, and they reduce the volume of waste by about 87%. So this waste as a fuel is also very much helpful also, because this is going to reduces the 2000 pounds of garbage. Like 2000 pounds of garbage will be there, and that is going to be reduced up to in the weight up to from 300 pound to 600 pound, and the volume of the waste is about 87%. So up to 87% the volume of the waste has been reduced into this chamber by the burning of the fossil this municipal solid waste. So by burning this municipal solid waste, they are going to reduce its volume about 300 to 600 pounds, and in this way their volume has been reduced up to about 87%. So now comes to the next point. This is the RDF. So RDF can be defined as the fuel that is derived from the combustible waste fraction of solid waste like plastic, wood, pulp, organic and other chlorinated material in the form of pellets or fluff produced by the drying, shredding, dehydrating and compacting of solid waste. So this definition has been given by the Solid Waste Management Rule 2016. Refuse derived fuel are the fuels that has been produced by the burning of solid waste, and as we know, in solid waste two type of materials are there: combustible and non-combustible. So all the non-combustible waste fractions, just like some plastic, wood, paper pulp or organic waste and other some chlorinated materials in the form of pellets will be there, in the form of pellets or some fluff, and that has been produced by the drying, shredding, dehydrating and compacting of solid waste. Composition of RDF has higher concentration of combustible material than those in the parent mixed MSW. So the composition of RDF is like having a very high concentration of combustible material only. So first thing is that all MSW is having two things. First is the combustible matter and the second is the non-combustible matter. So combustible matter are generally what are these things? These are like plastic, wood, uh, pulp or organic waste, and some chlorinated material will be there. So in the form of, it has been converted into the form of a small pellets or some fluff. So they are going to be produced. How it has been made? It has been made by the method of drying, shredding and dehydrating. By the method of drying, then shredding will be there and then dehydrating will be there. And compacting of solid waste is there. So you can see that this is the picture. At a source, reduction and reuse will be there. So after that it is going to be recycling and then composting. So then next step will become, that is waste to energy. So composting is the process which is mostly preferred for the organic material, organic waste, because composting is, again, it will be converting the waste to some compost. It is also converting some resource from the waste. Next is the waste to energy. So if it will be there, then landfill will be there. If it is not possible for the waste, either to go for the composting, either to go for the waste to energy, then that waste is going for the landfill also. So for reducing the waste, what we are doing, first thing is that at source we are reducing and reusing the waste. Next we are doing the recycling of the waste, and after the recycling, composting will be there. So from composting, it is going to produce waste to the energy. So this is the most preferred source and this is the least preferred source. Refuse derived fuel is integrated solid waste management hierarchy. You can see that this is the integrated solid waste management hierarchy. So what we are doing for the solid waste management, first thing is that either we are going to do the reduction in the waste or reuse of the waste at its source only. Then after it went for the recycling process. So from recycling, either if some waste will be left, it will be going for the composting process. Then after composting, if it will be some combustible material will be there that cannot be converted to the compost, or on that will be not in the organic in nature. So for this type of waste, we send that waste for the waste to energy, either for the incineration process or for burning in the turbine, burning in the boiler to produce the steam. To produce steam. Next, if at all it is not possible, then it is going for the landfill only. So you can see that this process is the most preferred, then after least preferred only. So now comes to the next point. You can see the quantity of RDF produced per ton of MSW varies. It will be varies or depends upon the type of collection, pre-processing and composition of waste source. So the quantity of RDF that has been produced per ton of MSW, it varies depending on the types of collection, pre-processing and composition of waste source. Quality of RDF depends on the characteristics of incoming waste feed, segregation into combustible and non-combustible. So the quality of RDF will mainly depends on the characteristics of incoming waste feed. Means the what is the means the RDF quality, like is it more burning or it will be not much preferred, what type of characteristics will be there for this RDF, it will be totally depend upon the waste feed. So RDF is the refuse derived fuel. MSW will be there. So from MSW, combustible waste is collected and form pellets. This pellet can be used for as a RDF. So the quality of RDF depends upon the characteristics of incoming waste feed. Segregation into combustible and non-combustible is a prerequisite. So first thing is to sending the waste to qualify is the RDF. It is like you have to do is to segregate into the combustible and non-combustible particle. Okay, so if it will be mostly in RDF, mostly which is having only combustible feed will be there, then it will be more useful. Then we can say that RDF can work properly. If non-combustible material is also there, then that RDF will be not much successful. Utilization of RDF fuel. So you can see that in the Indian coal, net calorific value of refuse derived fuel versus the coal. So this data has been given from the Municipal Solid Waste Management 2016. Yeah, industry require high calorific value fuels like iron and steel, like 9,000 kilocalorie. Using waste as a fuel become impractical. However, for the industries such as cement and cements, they require low calorific value fuel. So the if cement industry will be there, they are requiring low calorific value fuel. Just like that, in case of the industry, some industry is requiring high calorific value fuel like iron industry or steel industry, like they needs fuel of around 9,000 kilocalorie. So they are using waste as a fuel become impractical, and it is not possible to using waste as a fuel in case in the industries like iron and steel industry. So and some industries are there like cement industry, they can work for the low calorific value fuel like 3,000 kilocalorie. So next is this refuse derived fuel will enter to the incineration. So in the incineration, what happened? Incineration is the process of burning hazardous material at a temperature which is high enough to destroy the contaminants. So at a very high temperature in the incinerator, it has been burned, and due to burning of the solid waste, the temperature is going to be destroy the contaminants. Incineration is conducted into a chamber that is called as incinerators, which is a type of furnace that has been designed for burning hazardous material in a combustion chamber. You can see that incineration can convert waste into ash and gases. So this is ash will be collected. So first we will feed the contaminated waste from this side, and it will enter into the combustion chamber. This is the first combustion chamber where air as a fuel, and then the fuel will goes for the second combustion chamber. In that combustion chamber, it is also burning at a very high temperature. Then what happened? Gases to the air pollution devices will be there, and from here bottom chamber will be there. Bottom chamber. So it is going to collect the ash from this bottom chamber. So incineration is conducted in an incinerator tank, which is a called as type of furnace that has been designed for the burning of hazardous material into a combustion chamber. Incineration is a waste treatment process that involves the combustion of waste at a very high temperature in the presence of oxygen and results in the production of ash, flue gas, and heat. Incineration is a feasible technology for combustion of unprocessed or minimum processed refuse and for the segregated fraction of high calorific value waste. So, incineration is a feasible technology. Incineration is a technology that will be feasible, and it will be for the combustion of unprocessed or minimum processed refuse, either for the unprocessed or very minimum processed refuse, and for the segregated fraction of high calorific value waste. So the potential for energy generation depends on the composition, density, moisture content, and presence of inert in the waste. The potential for the energy generation is basically depends upon the composition, density, moisture content, and presence of inert material in the waste. So this is all about the incinerator. Incineration is kind of waste treatment process which is going to involve combustion of waste at a very high temperature in the presence of oxygen, and that will be results in the form of the ash, flue gas, and some heat. This technology is feasible for the combustion of unprocessed or minimum processed refuse, and for the segregation fraction of high calorific value waste also. So incineration is feasible when there is no better option of processing waste, shortage of land for landfilling. So like in case of Japan, they are having land storage also. So if your country is having land, less land, or you have shortage of land, so for there it is a very good option. So on the downside, incinerator is an expensive technology, and the ash remaining after the process completion can be harmful for the environment if it will be not treated properly. The primary difference between waste incineration and other combustion system is that the waste incineration process treats incoming waste into a great variation. Incineration of waste helps to reduce the landfill volume also. So the incineration of MSW will going to help the reduces the landfill volume also. In a furnace, the combustible components reacts with oxygen of the combustion air, and it is going to release a significant amount of hot combustion gas. It is going to release a significant amount of hot combustion gas. The moisture content of the waste is evaporated in the initial stage of the incineration process, and incombustible part of the waste from the solid residue like bottom ash and fly ash. The moisture content of the waste is evaporated at the initial stage of the incineration process, and incombustible part of the waste from the solid residue like some bottom ash or fly ash. Through the incineration, the solid constituents of the waste undergoes a range of processes. It will enters for the range of processes, and that will results for the exposure to heat and contact with the combustion air. So this is about the incineration process. Incineration process is like the combustion components. They are going to react with oxygen of the combustion air, and it is releasing a significant amount of hot combustion gas. The moisture content of the waste is evaporated in the initial stage of the incineration process. The moisture content of the waste is evaporated in the initial stage of the incineration process, and incombustible part of the waste from the solid residue. So next what happened through the incineration, the solid constituents of the waste undergoes a range of process which results as an exposure to heat and contact with the combustion air. The combustion gas from the furnace to the afterburning chamber. So from the European Union (EU), a minimum temperature of 850 degrees Celsius for municipal waste and 850 degrees Celsius for MSW and 1100 degrees Celsius for hazardous waste. Okay. So they have set a minimum temperature. So this minimum temperature will be required for MSW waste is 850 degrees Celsius, and for hazardous waste it is like 1100 degrees Celsius. So this has been set up for the complete burnout of the combustion gas in the after burning chamber. So as per the EU is like European Union. European Union has made standards for the combustion process. So this combustion gases passes out from the furnace to the afterburning chamber. As per EU, the above temperature should be maintained for a minimum time of 2 seconds as measured from the least injection of combustion air. So this is like maintained for a minimum time of 2 seconds as measured from the last injection of combustion air. European Union has strict legislation as to no feeding into the incinerator before attainment of required temperature. If at all there is any interruption such as drop in the temperature, then feeding should be stopped right away. So this EU has strict legislation as to no feeding into the incineration before attainment of required temperature. And if at all there is any interruption like a drop in the temperature, so then the waste feeding should be stopped right away, because they have a very strict regulation and rule upon the feeding of waste to maintaining the temperature For the attaining the temperature for the particular waste, some standards should be followed. But if there is any interruption, like drop of the temperature, then this feeding should be stopped right away. So in India, this is the whole cross section of the typical waste incinerated plant with a moving grate furnace and horizontal steam boiler generating energy from both power and heat. So in India, as per the C4 Manual 2016, minimum gas phase combustion temperature of 850 degrees Celsius for MSW and a minimum residence time of the flue gases above this temperature of 2 seconds after the last incineration air supply should be followed. So this, you can see, this is the cross-sectional picture of a waste incinerator plant with some moving grate will be there and horizontal steam boiler will be there. So they are generating the energy in the form of both power and heat. So you can see this has been given from the numbers also, like number 1 is the tipping hall. This is there where the feed will become, which is used for the waste feeding. 2 is like waste bunker. Waste will be collected here. 3 is grabs. 4 is a feeding chute will be there. 5th is the moving grate incinerator. 5th, you can see that some moving grate will be there. 6 is the boilers from where steam has been generated. 7 is electrostatic precipitator is also installed in this incinerator because they are basically burning the solid waste. So by the burning of the solid waste, some harmful gases will be coming out. So to filter out these gases, electrostatic precipitator has been installed again. 8 number is the DNOx catalyst will be there, then economizer. 9 number, 10 is the spray dryer. 11 is again fabric filter is also there. They have been also used to filter out the toxic gases. Then fan is there. Stack will be there, so it will be going to collect all those things. Like 14 is the bunker air extraction. 15 is the primary air fan. 15 number, you can see that this is the primary air fan. Then 16 is the recirculation fan and 17 is recirculations. 18 number is the turbine and 19 is the residue silo. Bottom ash and 20 is again the bottom ash bunker. So they are collecting the bottom ash from this incinerator burning by the burning of the fuel to the waste feeding, and this incinerator has been collected at the bottom of the tank. So incinerator can be designed before designing an incinerators. These are the basic considerations. So best available data on the amounts of waste, waste composition, and waste type. Waste composition and waste type is a very important factor for designing an incinerator plant. Effects of future change in the waste management. Waste laid to the incineration plant consists of some domestic, commercial, institutional and industrial waste, like great variation will be there. So the waste which leads to the incinerator plant is basically consists of either some domestic, commercial, institutional and industrial waste. Next is the street sweeping and construction and demolition waste are not suitable for the incineration as they contain a large fraction of incombustible matter. Obviously, for the waste, only combustible waste will be required. For incineration, only combustible waste will be required. So, construction and demolition waste is not applicable. Next, come to the history of this incinerator, when this incinerator has been made. So first incinerator developed in the UK in the 19th century. Waste incinerator plant treat waste of great variation in the composition. So waste incinerator plant will be there. This plant is going to treat the waste of the incinerator with a great variation in the composition. Moving grate technology was developed in the year 1920 and 1930. And it has been developed as a combination of grate with the rotary kiln in few years thereafter. Electrostatic precipitator is there to remove most of the dust in 1970 and 1980. In 1989, the European Union (EU) directive enforced some legislation on waste incineration that led to the present rule of 2 second residence time of the flue gas at the minimum of 850 degrees Celsius. So the residence time of the waste inside the incinerated chamber is like 2 seconds only, and that will be also having a minimum of 850 degrees Celsius temperature. So in the 89, the European Union will enforce the legislation on waste incineration that led to the present rule of 2 second residence time of the flue gases at a minimum of 850 degrees Celsius. So these are some of the references of some of the textbook. So this is the brief history about the incineration, like when this incineration has been developed, from when this incineration has been started. So the incineration has been started in the UK in the 19th century from UK. So this incinerator plant treat waste of great variation in the composition. So from starting time, it has been started from the UK in the 19th century. Then after at that time, mixed waste incinerator plant is going to treat the waste at a very great variation in the composition. Like the composition variation will also be there, then also they can use it for the incineration process. Then after, in the year 1920 and 1930, two type of technology has been developed. So this first is the moving grate incinerator technology, and next is the rotary clean incinerator technology. So first moving grate technology has been developed in the year 1920. Then after, in the year 1930, rotary clean incinerator has been developed. So then after that, some development will be there, and that development is again added the electrostatic precipitator to remove the dust in the air. Because what happened, inside the incinerator we are going to burn the MSW. So by the burning of MSW, some air will be coming. So that air is like some contaminated gas is there into that air. So to filter out this contaminated gas, electrostatic precipitator has been added to remove the most of the dust into the electros from this incinerator. So in the year 1989, the European Union directive enforced legislation on waste incineration. So in the year 1989, this European Union again directive enforced the legislation on the waste incineration that led to the present rule of 2 second residence. Means they have made one rule for the 2 second residence time of the flue gases. So this 2 second residence time of the flue gases is like minimum at the temperature of 850 degrees Celsius. The flue gas should be remain inside the incinerator chamber up to 2 seconds only. So the residence time of this incinerator is 2 seconds only. Okay. So now comes to this point. This is about the references of some of the textbook that you can use to follow this study in this book. So you will get some detailed study about all these topics. So now I am concluding my lecture. In this lecture, I have discussed about the refuse-derived fuel. Refuse-derived fuels means the fuel, some pellets or some fluffy should be derived from the combustible matter of the waste. Because in the waste, so MSW waste, two type of matter will be there, combustible and non-combustible. So from non-combustible waste, this RDF has been made. This is called as RDF. Then again, what happened? This waste has been used as a fuel in the boilers, and by the steam, by the burning of waste, steam has been generated, and through this steam, electricity has been generated. Then after, we discussed about the incinerators and how these rules has been made on incinerator, what are the history behind the incinerator, how many type of incineration was there. So thank you for today's lecture. If you have any comments, if you have any question, you can write in the comment box, or you can directly mail me onto my given mail ID, shikha.pandy@gmail.com. Thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.